Hello and welcome to Algebra 1, Dividing with Variables and GCF Factoring. So in this video we are going to divide polynomials by monomials. So we're going to apply the quotient rule of exponents to divide expressions with variables. And then we're also going to factor polynomials by using the distributive property or reverse distributive property. And we're going to determine and factor out the GCF of expressions that include rational coefficients and variables with exponents. Here are some of the standards that we're going to cover in this video. These are from the Florida's Best Standards for Mathematics. So let's go ahead and get started. When we divide with variables, we're going to treat the coefficients like a fraction and simplify. And then we're going to subtract exponents of corresponding variables. So first you might get a problem that looks more like this, where they're using the obelisk or the division sign. And all that means is this is going to be underneath all of these. And so here's one way that I like to rewrite it. So I'm going to rewrite what's in the parentheses. And then it's being divided by 8yz. So you might see it something like this. Either way, whenever we're dividing, we can write that up underneath each term. And so I'm going to put 8yz, 8yz, and 8yz. And then from here, we're treating the coefficients like a fraction. So I'm looking at 4 over 8. 4 over 8 gives me 1/2. And so if you don't know how to do this in your calculator, we have 4 divided by 8. And then it gives us a decimal, but oftentimes it's not going to be written as a decimal. And so to change it back, you're going to hit second and then this F to D button in the bottom left corner. So that gives us 1/2. And so now I have 1 over 2. Then from here, I'm going to subtract the exponents of corresponding variables. So I have a 2 up here and a 1 here. 2 minus 1 gives me 1. So if it helps, put a 1 there until you're ready to write out your final answer. And then for my z's, I have a 1 and a 1. And so 1 minus 1 is 0. And so the z is now going to be gone. Remember that anything raised to the 0 power is just 1, and so that would be taking this 1/2 y1, or 1 to the first power, and multiplying it by 1, so it disappears. And the 0 also tells you how many of that variable you see. So if I have a 1, I can see the y, but if I have a 0, I don't see it anymore. All right, and then let's go ahead and move forward. So now we've got 8 divided by 8, so that's going to be positive. And then we've got a 1 on the top. And then we've got y to the first power, y to the first power, and so 1 minus 1 gives me 0, and so those are gone. If it helps you with kind of crossing through these as you go, then do that. Then we've got 2 minus 1, and that gives us 1, so we have z to the first power. And then 3 to the 8th. If you're not sure, you can always plug it into your calculator. 3 divided by 8 equals second F to D, and it still gives us 3 divided by 8. And so don't be afraid to use your calculator to simplify. So now we have 3 divided by 8. And notice how whenever I'm writing my variables or I'm dividing and doing the quotient rule, anytime I'm getting what I have for my variables, I'm putting that in the tops. So just kind of keep that in mind. All right. So for this one, notice that there's a y down here, but there's no y on the top. So the y is going to remain on the bottom. Okay, it's going to remain on the bottom. We didn't do anything with it because we didn't do any subtracting. And then from here, we have z to the third power and z to the first power. 3 minus 1 gives us 2. And I write my answer on the top. The y wasn't an answer. It's something that was already there, and we just didn't do anything with it. All right, now that I have this, I can write out my answer. So I have 1/2 y, and I don't need to put to the first power, plus z, because I don't need to write the 1 as a coefficient or the 1 as the exponent, plus 3/8, and I can keep that z up in the top and the y down in the bottom. And that's going to be my answer. Let's go ahead and go on to the next one. So for this one, notice that they wrote it more as a fraction, and so what we're going to do is we're going to rewrite the top. And then this denominator here, we're going to put underneath each one. Okay. All right, so for this one, we have 9 divided by 3, which gives us 3. Then we've got 3 minus 2 on the m's, which gives us 1. And then we have 1 minus 1, and that is going to cross out. Then we've got a negative 18 divided by 3. That gives us negative 6. 2 minus 2, that's going to go away. And then we have a 2 minus 1, and that's going to leave us with 1. And then we've got negative 3 divided by 3. That gives us negative 1. And then 2 minus 2. And then 1 minus 1. And so that's just going to be minus 1 on that one. And then we're going to check to see that it's in standard form. We have m, n, and then a constant. And so we're good to go on that one. All right, let's try this one. Same thing. We're going to rewrite what's in the top. And then on the bottom, we're going to have this 2h divided by 3. All right, so don't get intimidated by fractions. So we're going to look at this as 4 divided by 2/3. So when I put this in my calculator, I'm going to say 4 divided by, and then 2 divided by 3. Remember how we always put our fractions in parentheses in our calculator. So for this one, clear it out. 4 divided by parentheses, 2 divided by 3, close parentheses, and then equals 6. And make sure you always hit your equal sign at the end, because if you don't, it's only going to show you what 2 divided by 3 is, which is 0.66666 on forever. So make sure that you're hitting that equal sign at the end. And this ends up being just 6, and so that makes it a lot easier. Then from here, remember this is 3 minus 1, and that gives us h to the second. And so don't be afraid. All right, next one, same deal. 6 divided by parentheses, 2 divided by 3, close parentheses, equals 9. And then we've got 2 minus 1, which is just going to be 1. And then for our last one, we have 3 negative divided by, open parentheses, 2 divided by 3, close parentheses, equals. And we get negative 4.5. So we want to get that back into a fraction. So I'm going to do second f to d. Now when you see this, that means negative 4.1/2. So when you see that, it's okay. And then do second ABC. And that'll give you negative 9/2. So negative 9/2. And then we didn't have an h in the top, but we did have an h in the bottom. And so that h is actually going to be underneath like that. Now let's go ahead and switch gears and go into factoring out a GCF, or greatest common factor. So the first question I want to ask myself is there a number, or what is the highest number that goes in all of the terms? And so when I'm looking at 16 and 40, I usually like to pick the smallest one and write out the factors for 16. So I've got 1 and 16, I've got 2 and 8, and then I've got 4 times 4, right? So what I'll do, instead of even listing them out, I just start putting them into my calculator. So I'm going to see if 16 goes into 40. So 40 divided by 16. That doesn't work. It ends up being a decimal, so it doesn't go in equally. So now I'm going to say 40 divided by 8. And that works out. So I know 8 goes into both. So 16 didn't work, but 8 did. And so if you need help with doing your greatest common factor, that might be something you want to kind of practice. But you can always write out your terms, or write out your factors, and then start with the largest one and see if it goes into the others. All right, so looking at this, I know that 8 goes into each one, so I'm going to put it underneath both. Then I'm going to say, is there a variable that shows up in all of the terms? Well, t is on the first one, but not in the second, and the same thing with y. Y doesn't show up in both, so it's just going to be 8. So that is my GCF. The 8 is my GCF. Now, I'm going to take my GCF, and I write it out to the side. Then I do parentheses, and then I'm going to divide just like I just did. So 16 divided by 8 gives me 2, and then I'm left with a t, and then negative 40 divided by 8 gives me negative 5, and then there's nothing with the y, and so the y just stays there. And then I close up my parentheses, and that's how you factor out a GCF. All right, let's try another one. So with this one, there's only 2 factors for 2, it's 1 and 2. And so I know 2 goes into 4. And so I'm going to put 2 on the bottom. Then I ask myself, is there a variable that shows up in all of the terms? Well, k shows up in both of these. So now I'm going to start looking at the exponents. I have a 2 and a 1. And so what is the lowest exponent? It's the 1. And so that is what I'm going to put in my GCF. Then there's no other variables, and so I'm going to write that GCF out on the side. I can keep the 1 for now to help me with remembering if I need to. 2 divided by 2 is 1. And then k, for the k's, I have a 2 minus 1, which is going to give me a 1. And I don't need to put a 1 here, but if you need to use it to help you remember, then that's fine. And then we've got positive 4 divided by 2. That's positive 2. And then we have a 1 minus 1, and so these are going to cancel out. and I'm going to close this up, and then I'm going to clean up my answer. Now that I have all this, I know that that's going to be 2k, I don't need the 1 as an exponent, times k plus 2. I don't need 1 as a coefficient, and I don't need 1 as an exponent. So this would be my answer. Now let's try one that's a little bit more complicated. So for this one, I have 3 factors now. The highest number that goes into each one is going to be 5. And then from here, I can see that there's a c in each one. And the lowest exponent on the c, well, they're all the same. They're all a 2. And so I'm going to put a 2 for my GCF. Then I can see that there's a v in each one. I have a 1 here, a 2, and a 3. And so the 1 would be my smallest. Now from here, I'm going to take my GCF, write it out to the side, and then I divide. So 5 divided by 5 gives me 1. And then I've got c squared and c squared, that's going to go away. V to the first and v to the first, that's going to go away. And so I'm just left with that 1. For my next one, I have negative 15 divided by 5. And so that's going to be negative 3. And then c squared and c squared, 2 minus 2 is 0. And then I have v squared and v to the first. So 2 minus 1 gives me 1. And then positive 5 divided by 5 gives me 1. And then I have that c squared and c squared. And then v to the third and v to the first. 3 minus 1 gives me 2. And then if I was rewriting this, I would just want to put what's on the inside of my parentheses in standard form. So I would still have the same GCF on the outside, but I would rewrite this in descending order. So I have v squared, I don't need the 1 as the coefficient, minus 3v plus 1. And notice that I made sure that all of my signs in front of each term remained the same. All right, so that wasn't that bad. All right, let's try one that looks even more complicated. So if you come across having to find a GCF and you're dealing with fractions, it's actually pretty easy. You're going to find the GCF of your tops, and then you're going to find your GCFs of the bottoms. And so you're doing them separately. So the highest number that goes into the tops is going to be 5. And then we're going to look at the bottoms. And so I have an 8, a 2, and a 4. And so that's going to be 2 is the highest number that goes into all of those. And now we can start looking at our variables. And I notice that a is in each one of these. I have a 2, and a 1. And so I'm going to put that here, a to the first power. And I have b in 2 of them, but not in the third. So I'm not going to include b into my GCF. And then from here, I put my GCF out to the side. So I have 5 over 2a, parentheses, and then I can just rely on my calculator for the rest of this. And so for this one, we've got clear, parentheses, 5 divided by 8, close parentheses, divided by, open parentheses, 5 divided by 2, close parentheses, equals. And then second f to d, that gives me 1/4. And then a squared, and then a to the first, 2 minus 1 gives me 1. And then I just keep going from there. So don't be afraid if you see fractions. Parentheses, 15 divided by 2, make it negative, close those parentheses, divided by, open parentheses, 5 divided by 2, close parentheses, equals negative 3. 2 minus 1 is 1, and then the b's doesn't have anything, so it's just going to stay as is. Then for my last one, so don't feel, especially when you're taking your EOC for Algebra 1, please, please, please don't feel like you need to do this fraction stuff by hand. You do not need to do keep, change, flip, or any of those things, or change the denominators into like denominator, nothing. Just rely on your calculator. So now we've got parentheses, 25 divided by 4, close parentheses, divided by parentheses, 5 divided by 2, close parentheses, equals second f to d, second ABC, and I get 5 over 2. And then plus 5 over 2. And that makes sense, and I'll show you why it makes sense. 2 times 2 gives me 4. 5 times 5 gives me 25. And so that's a quick way of how to do it kind of mentally, but rely on your calculator, that's okay. All right, so we've got A to the first and A to the first. Those are going to cancel out, and so I'm just going to be left with B on this last one. And there you have it. Let's try one more using an area model or box method. So when we were doing multiplying by binomials, we were using an area model or box method. You can also do that same thing for factoring. So let's say what they gave to us on the inside of the box is the area of a rectangle. And then they gave us the width, but they're asking us for the length of the box. And so what we can do is we can split these terms up where we see our positives and negatives, and then think, 9 times what gives me 9 that would be in the box? That would be 1. Then I have 1x on this side, but I have 3 in the box, and when I'm adding, I would need to have 2. And then for this one, I've got 9 times what gives me 36. That's going to be a positive 4. And then I have 1x on this side, so I need 1x on this side to have 2 x's inside the box. And then for this one, 9 times negative 2 gives me 18, and then I already have 1x on the outside of the box, and I have 1 inside the box, so I don't need any more. And so that's a way of factoring using the area model. So you might see it something kind of weird like this. And so the length would be x squared plus 4x minus 2, and that's already in standard form for us. I just cleaned up the coefficients and the exponents. And that's how you divide with variables and do a basic GCF factoring.